So once again we'll come back to the circular motion. So now we know in circular motion there is some acceleration which is always present. What is that acceleration? It is known as the centripetal acceleration, right? So this object is performing circular motion, okay? So there will be always some acceleration acting on it, which is along the radius and towards the center, and we call it centripetal acceleration, okay? So AC is equal to what? mv square upon r, and in vector form if I want to write, AC bar is equal to mv square upon r multiplied by r cap with negative sign. Why negative sign? Because r cap will be directed from the center towards the position of sorry, so r cap will be directed from the center towards the position of particle, and centripetal acceleration acts in opposite direction to that, okay? So now there is acceleration. Can an acceleration be present without the presence of force? There cannot be an acceleration without a force. Okay, Newton's second law says that force is equal to mass times acceleration. So that means there has to be some force always acting on a body performing circular motion. Okay, so though the body performs uniform circular motion, there would be some force acting on it. And what will be direction of that force? It is along the radius and towards the center of the circle. Okay, because acceleration is along the radius and towards the center of the circle. So this force is known as the centripetal force. This force is known as what? The centripetal force, because it acts along the radius and towards the center of the circle. So I will denote it by FCP, and it is just equal to mass multiplied by the centripetal acceleration. Okay, so it's equal to minus of mv square divided by r multiplied by r cap. So now the question is, which entity provides this centripetal force? Okay, which is the entity, which is that thing which provides for this centripetal force? So answer can be different depending upon the situation. Okay, so for an example, if you have a stone which is tied to a string and you whirl it in a circle, then there will be some tension in the string, right? So if you take a stone, you tie a string to it and whirl it in horizontal circle like this, okay? So you hold the string in your hand, okay? So you are pulling on the string, right? So there will be tension in the string which is directed towards the rigid support, which in this case is your hand, the center, okay? And the tension in the string will provide for the centripetal force. Then we can think of some other case. For an example, an electron revolving in an atom. So let's suppose this is an electron revolving in the atom. Okay, so in this case the centripetal force will be provided by what? So we know the center of the atom is positively charged, right? This is positively charged, the nucleus is positive, okay? So there is force of attraction between positive charges and negative charges. So here this centripetal force is provided by the electrostatic force of attraction between the electron and the nucleus, okay? So what can I write here? In this case, FCP, that is mv square upon r, is equal to tension, okay? So in this case, T is equal to mv square upon r, and in this case I can write that it is the electrostatic force. So mv square upon r is equal to what? 1 upon 4 pi epsilon naught multiplied by charge on nucleus, which is q, multiplied by charge on electron, small q, upon r squared. Okay, if it is the earth revolving around sun, then in that case we can write centripetal force is provided by the gravitational force of attraction. So at different cases, okay, in different cases the centripetal force is provided by different things. So we have to identify which is the force, which is the real force which is causing the centripetal acceleration. Okay, so it will be always caused by a real force, and we have to identify which is that force which is causing the centripetal acceleration. So got this? Let's think of a car moving along a turn, okay, taking a turn. So it follows a circular track, right? A turn can be thought of as a part of a big circle. So this is a car which is moving on this curved road. Okay, so let's suppose this is a car, right? So now it is performing circular motion. So can you tell me what would be the force acting on this car which is providing the centripetal force? Okay, so to answer this question, think of an oily road or a wet road, okay, and your car is taking a turn on that wet road. What happens? It skids, right? And in what direction does it skid? Away from center. Okay, it skids away from center. So which is the force that keeps that car from skidding? It's this it is the frictional force, right? Yes, no. Which is the force which keeps the car hold? Okay, sorry, which holds the car on the road? It's the frictional force. It avoids the skidding of the car. So skidding will be in this direction. If there is a skidding, okay, it will be in this direction. So the frictional force is acting in opposite direction to that. So skidding is away from center. Frictional force therefore acts towards the center. So it's the frictional force which provides for the centripetal force. Okay, so it is the frictional force which provides for the centripetal force. So Fs max. So now I want to find out the maximum safety speed of this car which is taking a turn on a horizontal road. Okay, so for the maximum safety speed, the centripetal force will be maximum. Okay, so it's the frictional force which provides for the centripetal force here. Okay, what are the other forces acting on the car? One is the gravitational force which acts downwards, and it is balanced by the normal reaction due to the floor, okay, the road, which acts upwards. So normal reaction acts upwards. Okay, N and mg. So for equilibrium in vertical direction, equilibrium meaning the sum of forces is equal to 0. Forces are balanced. That's why there is no acceleration in that direction. Okay, so for vertical equilibrium, what can we say? That N, the total upward force, is equal to total downward force. N is equal to mg. And for the equilibrium in the horizontal direction, actually not equilibrium, there is an acceleration and it is provided by the frictional force. Okay, the centripetal acceleration here is provided by frictional force. Okay, so I can say Fs provides the centripetal force, and therefore for maximum speed, for maximum speed it will be FCP will be maximum. Okay, so centripetal force, maximum centripetal force is equal to Fs max, and therefore we can write that mv square upon r, m into v max square divided by r is equal to what? What is the maximum frictional force mu multiplied by the normal reaction. And what is normal reaction? It is mg. So it is mu times mg. So now you can cancel out this m and you can take the r on the other side. So what do you get? You get that Vmax square is equal to mu times g multiplied by r, okay, or mu rg, or you can take square root and you can write that Vmax is equal to square root of mu rg. Okay, so the safety speed limit along a curved road is what? Square root of mu rg. You would be seeing the boards on a curved road, okay, 20 kilometers per hour is the speed limit, right? So this is how they find it out. So it is square root of mu rg. So mu is the coefficient of friction between tires of your vehicle, okay, and the road surface. R is the radius of curvature of that curve, okay. So that curve will be a part of big circle. So radius of that circle is the radius of curvature of the road. G is acceleration due to gravity. So this is how we can find out the safety speed limit, okay. But now we cannot rely on this safety speed limit. It is because the coefficient of friction, it depends upon the weather conditions. I mean, by weather conditions, I mean that if the road is oily, okay, some oil gets sprayed or it becomes wet in rainy season, what happens? The coefficient of friction will decrease. So especially in the hilly regions, what do they do? Because see, if your vehicle gets skid on a horizontal road surface, that's fine. But if that road surface ends up in a valley, it is not fine, right? So you cannot rely upon this formula to get you the maximum safety speed limit, okay. So to avoid skidding of vehicles along curved roads, what is done? Banking of road is done. So the this procedure of raising the outer side of the road with respect to the inner side through some angle, this is known as banking of roads. And we'll see how does this provide the centripetal force even in the absence of friction. Okay, so this trick, how does it provide for the centripetal force? So for that, let's draw this once again. So this is the vehicle, okay, moving on this road. So I have drawn this part only, okay. So now what are all the forces acting on this vehicle? So one would be the gravitational force acting downwards. We can very easily write it down. Then one would be the normal reaction due to this road surface, it is in this direction. And one would be the frictional force. What will be the direction of frictional force? Slanting downwards or slanting upwards? So in what direction will it skid? Away from the center, right? Center is like this. Okay, center of this circle is like this. So it skids away from the center, and your frictional force, it opposes this skidding. Okay, so frictional force will be acting like this. You got this? Yes, no? Okay, so frictional force will be acting like this, slanting down. Okay, so it's not upwards, frictional force will be in this direction. So let us draw frictional force will be in this direction. So now this is the normal reaction, this is the gravitational force mg, and this is the frictional force. Now the centripetal force is provided by this frictional force, component of frictional force, and a component of normal reaction. So what we can do is we can resolve the normal reaction and the centripetal force along upwards, I mean the vertical and horizontal components. So let's do that. So let's suppose angle of banking, this is the angle of banking. So this is equal to theta. So what will be this component? What will be this component of frictional force? Fs cos theta or Fs sin theta? Tell me. It will be Fs cos theta. Okay. So this angle is theta. That means this angle will be theta. And component through the angle is cos component. So this is Fs cos theta. Okay. And the component in this direction will be what? Fs sin theta. And similarly, for normal reaction, we can resolve it along two components, one vertical and one horizontal. So this vertical component. Now, here, this angle is theta. This is 90 minus theta. So this angle will be theta. Right? This angle is theta. Sorry, this angle is theta. This is 90 minus theta. So this will be what? Theta. So this angle is equal to theta here. Okay. So can you see this? So what will be this component? This will be n cos theta. Right. And what will be component in horizontal direction? It will be n sin theta. So component here will be n sin theta. Okay. So we'll draw it here and I will write it by this color, n sin theta. So now tell me, what are the components providing for the centripetal force? It is Fs cos theta plus n sin theta. Okay. And for vertical equilibrium, we can say total upward force is equal to total downwards force. So this resolution part is understood, everybody? Okay. So now for equilibrium in vertical direction, what can I say? Total upward force is equal to total downward force. So n cos theta is equal to Fs sin theta plus mg. Okay. And then I will move this Fs sin theta on left hand side. So I will write this as n cos theta minus Fs sin theta is equal to mg. I will call this equation number 1. Then the horizontal components of Fs and normal reaction provide for the centripetal force. Okay, so the horizontal components of Fs and N provide centripetal force, and therefore we can write that centripetal force FCP is equal to what? The horizontal components. This Fs cos theta plus n sin theta. So n sin theta plus Fs cos theta. And this is suppose equation number 2. Then I will divide equation 2 by equation 1. Okay. So dividing equation 2 by equation 1. What do I get? So dividing 2 by 1. I get n sin theta plus Fs cos theta, n sin theta plus Fs cos theta is equal to, this is FCP, which can be written as mv square divided by r, and I want to divide this with the equation 1. So equation 1 is n cos theta minus Fs sin theta equals to mg. So n cos theta minus fs sin theta, and on right hand side it is mg. Okay, so this m and m gets cancelled out. So m and m gets cancelled out. On right hand side you have v square upon rg, and I want to find out v. So I will write it as v square upon rg is equal to n sin theta plus fs cos theta divided by n cos theta minus fs sin theta. And I want maximum safety speed. Okay, so on left hand side I will write v max. Okay, maximum safety speed is what I want. So this will be fs max, right? This will be fs max. So can you see that max? Okay, so n cannot change, only frictional force can change, and I want maximum safety speed. So here I will take maximum value of frictional force also, because only then the numerator will be bigger. Okay, and denominator will be lesser. So if denominator is small and numerator is big, so total quotient will be big. All right, so then we can write this as n sin theta plus, this can be written as mu s multiplied by normal reaction multiplied by cos of theta, and in denominator you have n cos theta minus mu s multiplied by normal reaction multiplied by sin theta. So you can cancel out something, you can cancel out n, you can take n common and cancel it out from all terms. Okay, so you get v square v max square upon rg is equal to sin theta plus mu s cos of theta divided by cos theta minus mu s sin theta. And then in order to simplify this, we'll divide this by cos of theta. Okay, so divide every term by cos theta in numerator and denominator. So what do you get? Or you can say you are taking cos theta common from the numerator and denominator and you are cancelling it out. So this will be sin theta upon cos theta, tan theta, and we are dividing by cos theta. So this will get rid of this cos theta here, and here we'll have cos theta upon cos theta, that's 1, minus mu s multiplied by sin theta upon cos theta, that is tan theta, right? So what do you get? If you divide the numerator and denominator of right hand side by cos theta, you get tan theta plus mu s divided by 1 minus mu s tan theta. Okay, and therefore v max square is rg multiplied by this thing tan theta plus mu s divided by 1 minus mu s tan theta, and you want v max, so it is square root of this thing. Okay, it is square root of this thing. So this is the formula for the maximum safety speed along a curved banked road. This is the total formula. Okay, so now are we complicating our life by doing all this? So it seems like we are just doing some calculation. So does this have some real implication? Okay, is there some significance of doing this banking of roads? So yes. Okay, even if there is zero friction till, okay, so let's suppose worst case scenario that mu s is equal to 0. That means friction is equal to 0. Worst case, still you can drive your vehicle safely. How? Put mu s is equal to 0. So you get V max equal to what? It's equal to square root of. Put mu s equals to 0 here and here. So it will be square root of Rg multiplied by tan theta divided by, you will have 1 only. So that means square root of Rg tan theta. Okay, so still you will be able to drive your vehicle safely. Okay, and this will be the maximum safety speed limit, square root of rg tan theta. How? What you have done is you have banked the road. That means the normal reaction, which was vertically upwards earlier, now it is slanted like this. So these are the components. Okay, so one component of normal reaction provides for the centripetal force. So even if the friction is absent, still the normal reaction, the horizontal component of normal reaction will provide for the centripetal force. Okay, so this is significance of banking of roads. Got this? A ball of mass 0.25 kg attached to the end of a string of length 1.96 meter is moving in horizontal circle. The string will break if the tension is more than 25 Newton. Okay. What is the maximum speed with which the ball can be moved? So this is simple, right? So there is a ball of mass, some mass, it is connected to string and it is whirled in a circle. So which thing provides for the centripetal force? It's the tension in the string. Okay. So for maximum speed, the tension will be maximum, right? So m Vmax square by R is equal to maximum tension. Okay. So Vmax square is equal to the maximum tension multiplied by R divided by m, and you want the maximum speed. So you take square root of this. Okay. And now substitute the values. So what is maximum tension? 25 multiplied by R is 1.96 divided by mass is 0.25. So this thing divided by this thing gives you 100 multiplied by 1.96 is 196, 14 meters per second, right? This will be the answer. Let's see the next problem. A 500 kg car takes a round turn of radius 500 meters with a velocity of 36 kilometers per hour. The centripetal forces. So first of all, convert the velocity to meters per second. Okay, so V is equal to 36 kilometers per hour. We'll multiply it by 5 by 18. So it is 36 divided by 18 is 2. 2 times 5 is 10. 10 meters per second. Right? And this is straightforward question. Centripetal force is asked, which is mv square upon r. Okay, so FCP equals to mv square divided by r. That is 500 multiplied by 10 square divided by r is how much? 50. Right. Option A. So 500 upon 50 is 10. 10 times 100. 1000. Good. Option A is the answer. A roller coaster is designed such that riders experience weightlessness as they go round the top of the hill whose radius of curvature is 20 meters. The speed of the car at the top of hill is between. We have to find out the speed of the car. So see, why do we feel our weight? Is because of, so let's suppose there is a person, okay, suppose this is me. So there is gravitational force acting on me which is in downwards direction. Okay, so I don't feel my weight because of the gravitational force. I feel my weight because of the normal reaction exerted by this floor. Okay, so this floor exerts an upwards normal reaction on me, and this is the reason why I feel my weight. Okay, so we feel the weight because of what? The normal reaction, not because of the gravitational force. Actually, the normal reaction is also because of gravitational force. Okay, so if gravitational force was not were not present, then the normal reaction would be zero. So in turn, it is because of gravitational force only. But how do we feel it? It's because of the normal reaction. Got this? Yes, no? So what is our weight? It's not the gravitational force. It is equal to normal reaction. So now, see, in this roller coaster, when the rider is on the top of the hill, okay, the rider feels weightless. So why so? It's because, see, there will be some normal reaction. If he is feeling weightless, that means normal reaction must be equal to 0. So his weight acts vertically downwards, it's mg, and now he is taking a turn like this. Okay, I mean he is moving in a vertical circle. So there must be some centripetal force. Okay, there must be some centripetal force, FCP, which is acting downwards. So what provides for the centripetal force? So it's very easy. Here, FCP is downwards. Okay, so it is net downward force minus net upward force. So it is mg minus the normal reaction. Okay, and if sorry, and if the person feels weightless, that means n is equal to 0. So FCP is mv square divided by r. It's equal to mg. So m and m gets cancelled out. V square equals to rg. That means v equals to square root of v equals to square root of rg. And what is r? It's 20. So 20 times 10, 200. So square root of 200, 14. Okay. So 14 and 15, somewhere between 14 and 15 meters per second. This is the answer. Is this clear? A gramophone record is revolving with angular velocity omega. A coin is placed at a distance r from the center of the record. The static coefficient of friction is mu. The coin will revolve with the record if. Alright. So gramophone. Do you know gramophone? So nowadays you can either see it in movies or in museums. Okay, this is old thing. Alright. So there is a disc. Okay. And you keep sorry, you keep a coin on that disc. Disc is rotating. Along with the disc, coin is also revolving. Okay, so which is the force which is providing for the centripetal force? So here the frictional force provides for the centripetal force. So now the question is, the coin will revolve with the record if. So now there is some angular velocity omega. So now centripetal force required for the motion must be less than the maximum value of friction. Then only it will revolve, otherwise it will skid. Okay, so we can say the FCP required is less than or equal to Fs max. Okay, so what is FCP? So now answers are given in terms of omega. So we will use the formula in terms of omega. So mr omega square, and what is Fs max? It is mu s multiplied by normal reaction, and because this is horizontal surface, normal reaction is equal to mg. Okay, you can cancel out m and m, so you get r omega square is equal to mu s multiplied by g, and you want r, so it will be less than or equal to mu s times g upon omega square. So answer is option C. Is this clear? A car of mass m moving on a level circular track of radius r. If μs represents the static friction between the road and tires of the car, the maximum speed of car in circular motion is given by. This is very straightforward, very simple. What's the answer? It's the option D. Good. Okay. So they should ask this type of questions. We have found this. The maximum safety speed on a horizontal curved road is square root of mu rg. Okay, so that's what it is. Right. Next question. A car of mass 1000 kg negotiates a banked curve of radius 90 meters on a frictionless road. If banking angle is 45 degrees, the speed of car is. Very straightforward. V is equal to square root of Rg tan theta. Okay, if friction is 0. So let's put the values. What is R? It's 90. G is 10. Tan of 45 is 1. So it is square root of 900. 30 meters per second. Option B. Okay. Next question. A car is moving in circular horizontal track of radius 10 meters with a constant speed 10 meters per second. A bob is suspended from the roof of the car by a light wire of length 1 meter. The angle made by the wire with the vertical is. Okay, so this is some question till now, right? So there is a car and there is a bob suspended in that car. Okay, so let's suppose this is the car and it makes some angle, right? The string makes some angle. So why does it make that angle? It's because the car is moving in circular motion, so string will get aligned in such a way that horizontal component of string will provide for the centripetal force to this bob. Okay, so now you can resolve this uh, tension in the string along two components. So this angle is theta. Let's suppose this angle is theta with the vertical. Okay, and we want to find the angle with the vertical only. So this is theta. So this is t. So this component will be t cos theta and this component will be t sin theta. So for this bob, the t cos theta balances the weight and t sin theta provides the centripetal force. So t sin theta equals to mv square upon r and t cos theta equals to mg. If you divide these two equations, what happens? Gets cancelled. Okay, tt gets cancelled. You get tan theta equals to v square upon rg, right? So theta is tan inverse of that, v square upon rg. Put the values. What is v? 10 meters per second. 10 square. What is r? Okay, we want to find tan inverse of whatever it is. What is r? R is 10, g is 10. So 100 upon 100, 1. So which is that angle whose tan is 1? 45 degrees. So what's the answer? It is in terms of pi. Option C. Okay, it is pi by 4. Pi is 180. 180 upon 4 is 45 degrees. So this is clear. Yes, no? Okay. Tamil Selvi? Okay, good. Let's move on to the next problem. Two stones of masses m and 2m are whirled in horizontal circles. The heavier one in radius r by 2 and lighter one in radius r. Okay, the tangential speed of lighter stone is n times that of the value of heavier stone when they experience same centripetal forces. Okay, so same centripetal forces, right? So FCP for first one is equal to FCP for second one. Okay, so that is, let's call it m1 v1 square upon r1 is equal to m2 v2 square upon r2. So suppose this is the lighter one, this is the heavier one. Okay, so then now m2 is 2 times m1, v2 is given, okay, not v2. So speed of the lighter one is n times the speed of heavier one. So this is n times v2. Okay, n times v2, and we have square of that. It is v2 square m1 upon r1, and heavier one has radius r1 by 2. Okay, so now everything gets cancelled out. So m1 and this m1 gets cancelled. R1, this R1 gets cancelled. V2 and this V2 gets cancelled. I mean V2 square gets cancelled. So you have n square is equal to this 2 and 2 from denominator. Take it to numerator. N square is 4. So n is equal to 2. Okay, very simple. A car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of car and the road is. Tell me the maximum safety speed, the maximum safe velocity. Option D, right? Option D. Okay, NEET 2016. Next question. One end of a string of length L is connected to particle of mass M and other end is connected to small peg on smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle will be. Okay, so you got the question. There is one end of string of length L is connected to particle of mass M and the other end is connected to a peg. Okay, like this. And it moves in horizontal circle. It moves in horizontal circle, right? With speed v. The net force on the particle is. What will be net force on the particle? So there will be tension in the string acting towards the center. So tell me. It is resting on horizontal table. So there is mg acting downwards. Let's use other color. Mg acting downwards. Normal reaction due to table upwards. Okay, they get cancelled out. What's the net force? It's tension only. Nothing else is there. Right? What is the answer? Tension in the string only. You got this? Yes, no? This is clear, no? Everybody. Okay. Next question. A block of mass 10 kg is in contact against the inner wall of hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Okay. The minimum angular velocity needed for the cylinder keep the block stationary when cylinder is vertical and rotating about the axis. So see, there is a cylinder there is a cylinder like this, it is rotating about an axis passing through the center, and there is a block of mass m, okay, which is resting against the wall of the cylinder. So have you seen something like this? Have you seen death of well? It is called as maut ka kuआ in Hindi. I don't know what is it called in Tamil. Death of well in fair or in a circus? Maybe not. It's okay. So this is like that. Okay, there is a hollow cylinder and this block is resting against the wall. Okay, so now this cylinder is rotating. So due to this rotation, what will happen? This block is providing some normal reaction. Okay, some normal reaction which is providing for the centripetal force. Okay, what are other forces acting on it? One will be the gravitational force acting downwards, right? One will be the gravitational force acting downwards, and since it doesn't fall, there would be frictional force acting upwards, right? Okay, so this frictional force is equal to mu multiplied by normal reaction, and since it doesn't fall, frictional force must be equal to what? The gravitational force. Okay, therefore it doesn't fall. Yes, no? Okay, and now with what speed it must rotate? Okay, such that the frictional force is equal to gravitational force. That's what we have to find. So here the normal reaction provides for the centripetal force. Okay, that means normal reaction is equal to what? Mv square upon r. So mu times normal reaction is equal to mv square upon r because it is providing for the centripetal force. Okay, this is equal to m times g. So m and m gets cancelled out and you get v square is equal to what? Rg divided by mu. Let's put the values. So v is equal to square root of that. So tell me what will be the answer. Radius is 1, g is 10, mu is 0.1. So square root of 100. So v is equal to 10. Right? And you want angular velocity. So v is equal to 10 and v is r omega. Right? V is equal to r times omega. How much is r? R is 1. Okay, so v equals to 10. It is r times omega, which is 10. So r is 1. That means omega is equal to what? 10 radians per second. Okay. Have you understood this, everybody?